Assalamualaikum and hi. My name is Shazana bint Hashim and I'm going to present adsorption of phosphorus using cockle shell waste. Agriculture has increased the amount of phosphorus discharged into surface water, leading to water pollution and environmental degradation. The permissible limit of phosphate in water is between 0.01 and 0.03 mg per liter. However, the non-stop demand economy of agriculture has caused excess phosphorus discharge, leading to environmental degradation, including water pollution. The uncontrolled amount of phosphorus discharge accelerates eutrophication and algal blooms. This situation causes an increase in biochemical oxygen demand and the failure of aquatic ecosystem. Cockle shells, which live behaviorally buried in the sediment, have grown in importance as a valuable ecological marine product in Malaysia, particularly on the west coast of West Malaysia. It contributes to about 93% of marine aquaculture production. They produce an abundance of shell waste that is dumped into landfills or along the seashores due to the expensive disposal procedure. The high amount of untreated cockle shell waste leaves an unpleasant odor and visual disturbance to the surroundings. Excessive amounts of phosphorus can be treated with the adsorption method. Calcined cockle shell waste contains more than 95% calcium carbonate by weight. They can be used as a low-cost adsorber material as they have shown good performance for the removal of organic and inorganic matters in polluted water. It shows promise in removing phosphorus from polluted water, contributing to the eutrophication reduction. Materials and method. For the adsorbent, first we have to collect cockle shells from Teluk Kerang Pontian, and then the cockle shell will clean up using tap water and brush to remove any debris. Then the shell will boil for 10 minutes at 100 degrees Celsius before being air dried at room temperature. The cockle shell will then dry in a drying oven at 110 degrees Celsius for 2 hours to ensure complete drying before being crushed with a pestle and mortar. And then the shell was ball milled using the dry milling method for 45 minutes at 500 rpm. Subsequently, the resultant micro-sized powder was sieved using a stainless steel laboratory filter with an aperture of 75 micron. Finally, the powder was calcined in a camber furnace and stored in a Ziploc bag. To produce the synthetic solution to test the adsorption process, 0.1433 gram of anhydrous potassium phosphate was dissolved in 1 liter of diurnous water to make a 100 ppm stock solution in a volumetric flask. Then 500 ml of the stock solution was diluted with 500 ml of diurnous water in another volumetric flask, bringing the concentration to 50 ppm. Finally, in a volumetric flask labeled as 10 ppm, 200 ml of a 50 ppm solution was diluted with 800 ml of diurnous water to make a phosphate solution at the desired experimental concentration of 10 ppm. Adsorption studies, the best method for removing phosphorus from synthetic wastewater is via the adsorption process. After the process of adsorption in orbital shaker, the adsorbate and adsorbent were splattered using filter paper. The adsorbate of 25 ml of potassium phosphate was added with 1 ml of molybdate reagent and 1 ml of amino acid reagent. The final concentration of phosphorus solution was measured using the UV spectrophotometer. The percentage of removal efficiency as well as the phosphorus sorption capacity were calculated. Different dosage of CCS adsorbent was added to a set of conical flasks containing 100 ml of 10 ppm phosphate solution. The solution adsorbent mixture were then incubated for 60 minutes in an incubator shaker set to 37 degrees Celsius and 150 rpm. The phosphate removal effectiveness and sorption capacity of various adsorbent dosage were calculated using equation 1 and 2. Various durations of 20, 30, 40, 50 and 60 minutes were used for the test. The other experimental conditions were kept constant with a 10 ppm initial concentration of phosphate solution and 1 gram of CCS for adsorbent dosage. The samples were placed on an incubator shaker with a 150 rpm agitation at a constant temperature of 37 degrees Celsius. FTIR was conducted to determine the presence of functional group of CaCO3 in the raw cockle shell sample and CaO in the calcined cockle shell sample. From the figure 1, the bands in the IR spectra with an adsorption range of 400 until 4000 cm inverse. Different types of pores are commonly absorbed in their range of regions since the function of the FTIR is to identify the functional group. For calcined cockle shells, the characteristic FTIR bands were observed at 710.89, 871.22, 1395, and 3341.07. For the treatment time experiment, the prominent bands were at 711.7, 871.42, and 1393.40. The difference between the three spectra was the observation of a new peak on the calcined cockle shell absorption spectrum at 3641.07 cm inverse. Scanning electron microscopy SEM used to observe the surface morphology of raw cockle shell RCS and calcined cockle shell CCS. Figure 2A shows the same image of RCS while Figure 2B shows the same image of CCS. The average diameter of the cockle shell powder particle was 10 micron, indicating the availability of a network of porous surface texture that result in higher surface areas for phosphorus adsorption. The RCS micrograph show a combination of stone and fine powder particles. On the other hand, the CCS micrograph illustrates a coral shape with space that grew larger as a result of the high calcination temperature. This space of porosity may be capable of trapping adsorbents during the physical adsorption process. Different adsorbent dosages were used to study the removal efficiency of phosphorus and the adsorption capacity for phosphorus from the synthetic wastewater solution. As shown in Figure 3, the phosphorus removal efficiency by CCS was proportional to the adsorbent dosage. As the adsorbent dosage increased from 0.2 to 1 gram, the phosphorus removal efficiency by CCS increased from 87.65 to 95.96. The higher removal percentage indicates more phosphorus is attached to the adsorbent surface at dosage. However, when adsorbent dosage was increased from 0.2 to 1 gram, the phosphorus adsorption decreased from 5.04 to 1.9 mg per gram. Phosphorus adsorption was initially quite fast, and longer contact time resulted in higher phosphorus removal. Phosphorus adsorption increased from 88.43 to 95.74 between 20 and 60 minutes as Figure 4. The increase in phosphorus adsorption may be due to the longer the contact period. In brief, CCS is an ideal substrate for increasing the rate of phosphorus removal. When duration of adsorption increased from 20 to 60 minutes, phosphorus adsorption capacity of CCS increased from 1.02 to 1.10 mg per gram. The CCS, which acts as a natural adsorbent, appears to be effective in removing phosphate compound from synthetic wastewater solution. The efficiency of CaCO3 from calcined cockle shell powder with the highest dosage of 1 gram has removed 94.96% of phosphorus in the synthetic wastewater. The interval time of 60 minutes showed that 95.74% of phosphorus has been adsorbed efficiently. From the result, the waste cockle shell is highly potential to remove phosphorus, had achieved up to 96% greater than the previous result. This convenience and low-cost research of cockle shell adsorption is useful and needed more findings in order to improve and develop greener technology that will only bring benefits to the environment. Contribution to society. First, environmental remediation. Phosphorus pollution in water bodies leads to eutrophication, causing harmful algal blooms and depletion of oxygen, which adversely affects aquatic life. It can contribute to the removal of phosphorus from water, thereby aiding in environmental remediation efforts. Second, waste utilization. Provide a sustainable solution by utilizing this waste material for a beneficial purpose, reducing environmental pollution and promoting the concept of circular economy. And the last one, community engagement, involve collaboration with local seafood industry for the collection of cockle shell waste, fostering community engagement and promoting awareness about environmental issues and sustainable practice. Here is achievement for this project, which is publication in Journal Industrial and Domestic Waste Management. Thank you.